this opportunity, and good morning from here, from Peru, and good afternoon for you that maybe most of you are in Europe, right? So today I'm going to talk about one-click 5G core using OSM. My name is Sergio Tarazona. I'm from Whitestack, and let's begin. Okay, the agenda for today. In this demo, we're going to see first the one brief introduction about ONI and Whitestack and all the work that we've been doing this time. Next, we're going to see the demonstration of an hybrid CNF and VNF scenario. This is for 5G core and the access part in order to test this call flow with this 5G core. And then we're going to see the next steps that we've been planning to do in the near future. Okay, first, we detected that MNOs need to have non-proprietary 5G SA core and RAN solutions for different use cases, starting from testing, and then maybe they're planning to implement private networks or FWA use cases and something like that. So we've been looking for a 3GPP compliant open source 5G core to start testing and develop a product in the near future. So ONI has several years of experience working in radio access network and core network technologies. So they have an active community working on delivering new features all the time. For example, they're working on Open RAN, network slicing, and some kind of new features. And we have good experience working with ONI in the past multi-vendor NFV environment. So there is high confidence on the joint capabilities to take this solution to production networks and environments in the future. Okay, for this demonstration, we have this basic architecture. So we currently have one public network in one VM. This is external server. We're going to run an iPerf here to test the connectivity and the traffic between the UE from the access part and this server. And then we're going to use OSM to create this VM for the access. We have here a simulator for GMB and UE provided by ONI. And also we have the 5G core SA. For this, we're going to use White Cruiser. This is a Kubernetes cluster provided by Whitestack. And the VM is going to run over White Cloud based on OpenStack. So here we have the network functions that we're going to deploy. We're going to deploy the UDM and UDR for users database, AUSF for authentication, NRF for registry, AMF, SMF, and UPF for control plane. Okay, using WhiteNFV, WhiteNFV is a OSM-based solution from Whitestack. We're going to deploy both VNF and CNF using one NS package. As we can see here, we have one NS package. And this package contains a VNF package for the GMB SIM to simulate the access part, the GMB and the UE. And we're going to include also the KNF for the 5G core SA for nodes. And this KNF is Helm-based, okay? And we're going to deploy all the network functions that we saw previously over a Kubernetes cluster. Okay, the Helm chart defined in the KNF has the following charts. We have, as we saw previously, UDR, UDM, UPF, SMF, NRF, USF, AMF, and one MySQL database. So what we have currently in the community ONI charts is that there are some limitations, like having to deploy them in a specific order. For example, we have to deploy NRF first because it's the registry for the network functions. And after this function is ready, we need to deploy the rest of them because all of them have to register with this NRF. So this NRF should be deployed first. And for the database, we need to, for the UDR, we need to have it MySQL deployed first. So for this case, and Whitestack is contributing with several optimizations on their upstream code. The idea is to achieve the zero-touch Helm-based and OSM-powered deployments of this 5G core. That's why we could deploy it as a one 5G core completely. Okay, I have a video here of the demonstration. I'm going to open it. You can see it, right?
Yes.
Yeah.
Okay, thank you. Thank you. Okay, so we're logging in WhiteNFV. And we're going to see the VNF packages that we have created. One is for GMB SIM. It's a VNF. It's going to be deployed in one VM. And we have another one for 5G core. It's a KNF. So it's going to be deployed on top of a Kubernetes cluster. And this has the Helm chart that we showed before. And then we have one network service package where we have the both VNF and KNF parts. So we have the VNF profile for GMB and one for 5G core. Okay, so now we are ready to instantiate this network service. So we're going to create it. We're going to put to set the name, description. We're going to choose the NSD and the Veeam account. Okay, so now it's being created, and we're going to see in the cluster, in the Kubernetes cluster, how this is going to be deployed. This is for 5G core. So here we can see that it's starting to create all the pods. As you can see, there is init containers to validate the creation of the previous network function. In this case, NRF is created first, and after that, the rest of the network functions are being created. And UDR is waiting for the MySQL database. That's why it's going to be created last. So far, we have almost done. Okay, so now we're going to see UDR up and running. So as we can see, this action took less than a minute. And we have the code part ready now. So we're going to see first the logs of the AMF. AMF is going to register the GMB and the UE. Because so far there's no GMB registered, so we're going to see in the logs that these fields are empty. And after we run the GMB, we're going to see that those fields are populated. Okay, here are the logs. As we can see, there is no GMB and there is no UE. So now we're going to see we're going to log in the VM for GMB, and we're going to run the GMB software. This is Docker based. And we're going to run it. And after this is running, we're going to see that this is up. And then we're going to check the IP that the core has given to this UE. In this case, is this. And now we're going back to the core and see if this GMB and UE are registered in the core. So here we can see that we have the GMB connected and we have the UE registered. So far the access part is okay. And now we are going to connect to the external server to run the iPerf as a server. First, we're going to get the IP. Here we can see the IP. And now we're going to run the iPerf. Okay, it's listening. So we're going back to the access part and we are going to run the iPerf. We're pointing to the iPerf server. This is the external server that we have. And we're using the interface of the UE. So here we can see that there is traffic between the UE and the external server with good throughput. And that's it. We have tested this 5G core just to confirm that there is no issues with the deployment. So that's why we use this GMBC. So now we're going to delete this 5G core just to see how fast it is to delete this environment. Okay. It's starting to delete, so we can go back to the Kubernetes cluster and see the pods. As we can see, the pods are going to be terminated in just a few moments. Okay, there it is. So this process takes more than the creation itself. So, but it's pretty easy to create the core, to deploy this core, and it's easy also to terminate this core. We have to wait just a little few moments to delete all the pods from the cluster. Okay, it's ready, and then we can see in WhiteNFV that there's no network service. Okay, that's the demo part. So I'm going back to the presentation. And the next steps, what we're planning to do in the near future. First, I would like to enhance this demonstration. We're thinking to deploy an extra UPF in the edge, integrated to the core using OSM in a multi-site fashion. So we're going to have the core in one cluster and the UPF in an edge cluster. It's what the MNOs in the future would like to have, a distributed 5G core. Then we're going to deploy additional testers using OSM. As we can see, we can deploy it. We deployed GMB SIM for this test, but we think that we can add more testers to this environment. We also want to include PNFs like firewall or CGNAT to provide access to internet. We think that this could be better. And also, we'd like to contribute to OSM Hackfest with the whole scenario, leveraging new OSM features with the goal of going beyond what was achieved with previously Magma. And finally, we would like to share this scenario with telcos, pointing to replicate similar ones with their production mobile platforms. So since this 5G core is usually it's being created using Helm charts, the integration with OSM should be pretty similar that we've done here. So this could be interesting for telcos in the future. And that's it. Thank you very much for your attention. And I don't know if you have questions regarding this.